right? So we can also talk about, the cloud formation, right? When you would want to replicate replicate an architecture to multiple, let's say, regions or multiple multiple regions or multiple ASICs, right? You can do all those configuration in cloud formation, and then now you use the cloud formation template to do your replication instead of doing them manually one after the other. And the second one is treating resources as disposable, right? So for example, there was a question in our knowledge checks that was like, I think a developer has a production environment, but they would want to test new technologies. What is the best practice to go about, right? What's the best practice to go about this? So one of the answer was the fact that the developer should replicate the production environment into a test environment, test the technology, and then when they are done, they can delete the test environment, right? And then revert back to go to the production environment and then implement their solution, right? So you treat your resources as disposable, because even over time, your servers, changes in configurations, right? There are different configurations that it may happen. Your resources even do run when they are not needed, right? So instead of using like your normal, like just like how our normal traditional infrastructure or traditional IT environment looks like, doing that will, put you at a lot of cost, right? Some of us who were charged for using EC2 instances for a long while, the fact that we didn't dispose them, we didn't treat them as disposable. We provisioned them, appreciated how the whole thing is done, and then we forgot, just logged out. The next thing we realized was that Amazon has sent us an email that this is our cost. Some of them, their card didn't have money, so they were alerted that they couldn't they couldn't charge your card. That is even how come they knew that they have something running that they haven't stopped or they haven't disposed. Right. So it is always recommended that you treat your resources as disposable, especially when you want to use them for test purposes. And then when you feel like you have used it or it has elapsed its usage period, right? It is best that you dispose them or you terminate it. That's why for instances or for database instances, you don't stop it, because if you stop it, you still pay for the storage. So it is best that you terminate them, right? And then if you look at the last point, it says what? Test update on new resources and then replace old resources with updated ones. So anytime your resources, anytime, like, just dispose them if they have no use. Put them somewhere or delete it. Anytime you need new one, you can provision a new one, use it, and then you put it out. In the case of IP addresses, so that's why the EC2 instance, the public IP, for anytime you stop and start, you are given a new one. You don't stick with one IP address for long. It even open you up for security threats. That is why it's hard. You see, a normal real life practice is when people hide their addresses. You see, it's very difficult. Sometimes it's very difficult for people to give out their addresses publicly, right? Even phone numbers and then all those things. You see, the celebrities, they treat their phones as disposable, even though they have their personal numbers that you can constantly reach them. But most of the numbers that they give out, they change them maximum 1 month. No assessor. And then building loosely coupled components. When we look at this diagram, you see what's This whole arrows is even funny. Now, what is happening is this. There are dependencies, or let me say interdependencies, right? These systems are has interdependencies. So what it means is that this one is dependent on this one is dependent on these three, this one is also dependent on these three. So what happens is that if this one stops working, or if this one crashes, right? If the application server here crashes, all these are not going to work, right? So it's like there are interdependencies. In tobacco crash, they are in trouble. The whole system is in trouble, and that is not a best practice. So what you do is that you do it this way, right? You decouple them, you loosely couple them. So here the best practice is introducing an elastic load balancer, where the load comes to the load balancer and then it is distributed evenly across the instances. So in this case, if this stops working or this is unhealthy, it doesn't affect the application doesn't go down. What happens is that the load, if let's say it's sending like 20 packets, right, the load will now stop. I mean, it will stop being distributed to this, and then now 10 goes here, 10 goes here, till this one is healthy, and then it will now evenly distribute them across. So that's what we mean by loosely decoupling them. So loosely decoupling them is just about reducing interdependencies. And then the fifth one says design services and not service. So most of the times when you are, let's say you want to deploy a web application, right? Most of the time the concentration is on the instance or the server that we are spinning up or we are provisioning, right? But then we don't just have to limit the whole thing to the server, right? You have to take advantage of the fact that you have a whole lot of services that you can use to actually make your infrastructure better. So instead of you building servers or putting just provisioning servers, your focus should be on putting out a whole service. So let's look at the e-commerce case study that were put in front of us. On a usual case or on a normal case, we could have just provisions the EC2 instance that will serve the web application and then probably the database, and then we are done. But what did we do? We looked at doing load balancing, we looked at auto scaling, we looked at implementing what an inspector to inspect the instances. We looked at implementing a CloudWatch. We looked at implementing web application firewall. There was guard duty, right? And even the S3 to store the static images. So it's a whole service that we architected, right? Not just putting up servers and then that was it. So in our architecting or in our quest to architect for people or architect solutions, we have to look at the whole thing as what as services, not just okay, EC2 instance, but RDS, we put it there and then it ends there. We have to make sure that we have like a complete package that we are putting out, or a complete solutions that we are actually architecting, right? So look at using containers and then serverless solutions for our application deployment and then our application packaging. We look at message queues to handle communications between application, and then hosting your static assets, right, in an S3 storage, right? And then using user authentication and then user state storage that are handled by managed AWS services. So more or less like you are just taking advantage. So here we can factor it to the which of the pillars of the well-architected framework? That is operational excellence, right? Is it operational excellence or professional? I say professional performance efficiency.
Those two always confused.
So performance efficiency is where you take full advantage of the capacity of resources, right? Using the right resources for the work. So if you would want to, you are putting up a robust service, you need to look at a server and then look at the right CPU size for the job, right? So it's like taking advantage of all the right tools and resources. And then operational excellence is taking advantage of, continuously taking advantage of technologies to improve your services.
And learning from mistakes.
Yes, and learning from mistakes, exactly. Okay. And then also choosing the right database solution. So always match technology to the workload and not matching workload to the technology. Right. So still on the e-commerce portal case study, you remember we were considering Aurora and RDS. And we decided that, okay, in as much as Aurora performs better than RDS, in this use case, it is best to use RDS, right? Looking at the fact that it's a startup, right? It's a startup, and then in as much as they will be doing a lot of read and write, for starters, it's best that we use an RDS for this service. And then considering the fact that they were also looking at cost. So for database, you have to look at the latency requirement, matching the concurrent users to support, and then the nature of the queries. Is it more reads? Is it more writes? Or is it a balance? And then the request strength of integrity controls. Right? So integrity controls, you are looking at like, CloudTrail, where it will log all user activities. Right. So always when deploying or choosing to architect database solutions, in some use cases, it will even be best to just do a custom EC2 instance and then you input your database, right? So you host your database software or database server on an EC2 instance instead of going for that. But in best cases, it's always best to use managed service and also avoiding single point of failure. So assume. So there is a saying that assume everything will fail and make everybody type on for the chat page. Assume everything will fail and make we all continue. I know they see any message. And now we have forgotten.
Is it assume anything will fail and
Assume
what?
everything will
Plan
fail
for and
and
plan for failure.
no. That don't mean the continuation. Oh, I see Flora for yeah, she left. Assume
Give me possible answers. People answer.
there is only one possible answer. Assume everything will fail.
Assume everything will fail. Design like
And nothing will fail. Correct. As you go, will sack you. What is redundancy? We'll remove your name from the ALS learners this thing.
It just seems to get that.
Yes, so assume everything will fail and nothing will fail. Right. So when you are designing, always assume that everything will fail. So when you are when you have that
AWS na cooks na abem.
is
Then
that
as
what?
Yeah,
you
wow,
everything for the fail.
yeah, wow,
Then solutions anthem na.
wow.
About since if you like days, I people forget.
No, it dey inside though, but you see, you no go put your head inside. But if you see for answer inside, you go pick up.
It will pick up.
Yeah, shit.
So anytime you are designing, you have to always, so where possible, use redundancy to prevent single point of failure. So you are looking at doing what? Multi-AZ. You have backup. In our use case, the e-commerce, you remember we did our RDS, the main RDS instance in one availability zone, and then we did the other in the second availability zone for backup purposes. Our auto scaling group was also scaling across multiple AZs, right? So that is it. Always avoid single point of failure. So if our availability zone one fails, the next one is there. So that's the part 2, and then the part 1. Sorry. So this is the part 2, right? So best practice: the application server, you create a replication database server for secondary. The same thing here, replication. So the main server goes offline, and then you have the replicated server working. So always put that in your mind, and then also optimize costs. So we can look at choosing EC2 options, right? So depend on your workload and then how you are going to use it. So you look at how often will you need to actually use a resource. Will you need it for a long time? Will you need it for up to a year? Then it's best I go for a reserved instance. Or in this use case, a savings plans best for me. Maybe I will use it the whole year, but I will not use it every, like, maybe for long. So maybe every day I'll use it for 1 hour, every day I'll use it for 2 hours. So then let me commit to this number of hours each day, right? And then reserve it for a year. Or okay, I have predictable workloads and I know that I'm going to use it like constantly every day. So then let me go for reserved. Even with a reserve, am I paying all upfront? Am I paying partial? Or I'm doing a no upfront reserved? So all those things you consider, right? If you are using service, are you looking at, okay, can I replace them with managed ones? Do I consider automating instead of provisioning each of the underlying infrastructure one after the other? Which one is most cost effective? So you look at all those things before, and then you have the flexibility of doing it, right? Maybe you have your own resources or services that you have control over, and then now you want to switch to managed services. Yes, it is possible to also do that. So it's like you continuously evaluate or audit or assess your infrastructure, and then considering what costs, and then now use caching or caching. Right? So there is an anti-pattern here. So the anti-pattern, the S3 bucket is there, has a data, and then the customer request goes straight to the S3 bucket, right? Which in turn creates a larger cost, and also there is high latency because the S3 buckets, yes, in as much as it's a global service, somebody might be in a place that is far from where the S3 bucket is available at. So it creates like higher latency, and then also for the cost incurred with the data transfer out is huge. The best practice is what? Using CloudFront, where CloudFront deliver the content very close to the customer. So in this case, wherever the customer is accessing the files from, it could be even their same region. So data transfer charges are low, and also latency is reduced as well. So that is the best practice for caching or caching. What is the best practice for data in the case of database, as far as caching is concerned, in the case of database, what's the best practice for that?
You go
In-memory
create
cache.
read replicas.
Yes, so read replicas, and then another thing. There is another thing too.
You
In-memory
go
cache.
use elastic cache.
Good. Yeah. So you do, I mean, in-memory cache with elastic cache.
Yeah.
Super. Right. I'm on for Bill. And then the 10th one, secure your entire infrastructure. Right. Securing your entire infrastructure. So build security into every layer of your infrastructure. So if we remember in the use case of the e-commerce thing, when we started, we provisioned our VPC, and then when we got to the subnet level, there was security groups for the instances, right? We also use web application firewall. Even with the DNS, we use RAS 53, which has AWS Shield inbuilt. CloudFront has the same technology, coupled with what the web application firewall. We also had guard duty, always on guard. We had inspector. We also had another thing, the one that had the fire in it. What was in it? What was in it?
It has what?
Fire. The logo is like fire. You forget.
I don't
Me
see
say,
any fire look.
me say if I forget. Or I know, or I remove them.
We do web application firewall. You get fire for inside.
That be what I did once, guys. Maybe, my uncle show me way.
Yeah, they say it has that.
LinkedIn people, then they won't like me make I do premium.
The premium there, if
That's
you
in the
get
way they
them,
bomb me.
they pop us.
Okay, that be the WAF. Okay, that be the WAF. So yes, the web application firewall, and we also implemented guard duty, and then we use security groups. We even placed our EC2 instance or the web application service in a private subnet, and then the traffic was just sent through the public subnets through an internet NAT gateway to the internet gateway. So it's like there's security at all levels. Even our S3, we use S3 encryption at rest. Talk of your account, you can also look at multi-factor authentication. So even your user at the user level or the account level, you have security there, right? There are access controls. You can also look at policies, access policies, resource access policies, and isolating part of your infrastructure. You don't put all of them together. You put everything at the right place, and also use managed service. So managed service has also some form of security, and also login access of resources. So you talk of the use of CloudTrail, right? And also automate your deployment to keep security consistent. So I talked about CloudFormation. So CloudFormation, you can have all your stuff, everything about your architecture configured in CloudFormation, so that when you are replicating, you just have the same thing going over and over again, right? Consistently without any changes, or yes, without any changes. Let me just put it that way. So that is basically about the 10 best practices as far as architecting solutions are concerned. So this is a summary. Summary is enabling scalability, automating your environment, treating resources as disposable, using loosely coupled component, designing services and not servers, choosing the right database solution, avoiding single point of failure, optimizing your infrastructure for cost, using caching, and also securing your entire infrastructure. That is enabling security or implementing security at all levels. So that's basically about the best practices as far as architecting solutions are concerned. Questions day, clarifications day, contributions day, additions.